Okay, I didn't see that button.
Okay.
Thank you, Mr. Merritt. Okay, we have 5 Algebra 1 students today. It's a good day. It's a good day for the best class of the day. I hope you will agree with me. If you don't, that's okay. You can still get a very, very, very good score in this class and disagree with me. So, because we're in day 5 of Algebra 1, which means there are only 172 school days left of Algebra 1. That's sad, isn't it? But only 172. I do want to go over all the housekeeping items. So,
We want to double check and make sure Anna can hear us and we can hear her.
Yes, Anna is alive and well.
It's working today. Excellent.
She can hear me. I can hear her.
Good deal. I'm glad it's working
My
finally.
life is really connected.
Okay, excellent.
And I have Lillian and Rebecca and Mr. Mark and Elizabeth. Okay. So, housekeeping item number 1. Welcome. Number 2. I have been receiving everyone's homework assignment, and I'm very glad to do that. Most everyone has been successful in having a good experience with their homework. I'm glad. My goal is that you will have a good experience with your homework. And by a good experience, I mean that you basically understand what you're doing. And I can tell that when you turn your homework assignments in. As a reminder, I think I have everyone caught up, but please make sure you have at least 2 things besides all the right answers to all the questions on your paper. Make sure also that your name is on there so I know who to give a very high grade to. And also the assignment. Because as you have found out, I am easily distracted and I get easily confused, and I do not want to be confused over your homework assignments. So, please make sure your name and also the assignment is on your papers. I think our routine, I've been handing back your papers in class, but everybody else I've been scanning and forwarding those to you as a scanned document. Hopefully you're able to figure out my grade when you get those papers back. Are there any questions about homework then, including yesterday's homework assignment, which I'll hand back to these individuals right now? Any questions? No? Wow. Yes, ma'am.
I have a question on a previous assignment.
Okay. You have 30 seconds. Go.
On the first one,
Which assignment?
The first lesson that we did, the number check one.
Okay.
Question number 1.
Question number 1.
Letter B.
Question number 1, letter B. Yes, ma'am.
It says, does your table prove the check will work for any number? And I put yes, and then you said it was no. But the drawing, isn't the drawing the exact same thing as the table? And if D was right, why isn't B yes also?
Okay, so this is on page
3.
Page 3. Number 4.
Number 1.
Number 1.
Letter B.
Letter B. Does your table prove that the trick will work for any number? Okay. So, here's the trick. The trick was that you were given 5 numbers. Those numbers were 1, 2, 3, 4, and 5. And when you run it through the trick, right, when you did all the steps, boom, 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 will it work for any number? In other words, if you stick in any number that you think of, will you always get 3? That's what that says.
Oh.
And the answer is no. Right? For instance, I'm going to think of a number right now that it won't result in 3. 0. I thought of the number 0. If you take 0 and double it as 0, if you add 6 to 0, you get, well, maybe 0 works. Let's try -1. Okay, so we can think of an example where it won't work. So the answer would be no. Is there another question?
I'm sorry. I need to steal some students. Chemistry students who I kicked out of lab. The lab is postponed. We'll have a study hall in the lab.
Are you kidding me?
We are
Okay.
no longer able to access the goggle cabinet. Come have a study hall.
Okay, so next, anybody else have a question on that one? Are there any questions over today's homework assignment? Okay, folks who are in here, we're trying to have class, thank you. Are there any questions over today's homework assignment? Mr. Daniel, welcome to Algebra 1 class, and you haven't been called on. Thank you. Are there any questions over the assignment due for today? Sir?
18C.
Okay. There's a question on problem 18C. Draw figures as indicated. A rectangle divided into squares to illustrate 4 times 5. Right? 4 times 5. Anybody else have a question? All right. So my online friends, if we ask a question in class, just as a reminder, and you may fix that problem, okay? So if that happens and you want to turn your homework assignment in immediately, or, well, either during class or immediately following class, you may do that rather than turning it in. Most of you have been turning it in the night before, but sometimes you may get into a situation where you don't understand a problem, you want to ask about it at the beginning of the class, and then you find yourself waiting a little bit, and that's okay, all right? That's okay. So let me collect these in class. All right. Well, yesterday we had a lot of fun with multiplication. And one of the things we said about multiplication yesterday is that multiplication, we can think of multiplication in 2 ways. And one way is that we can think of it in terms of what other operation. We can think of it in terms of, we can think of multiplication in terms of what other operation out of the 4. Add, subtract, multiply, and divide. Lillian?
Repeated addition.
Right, repeated addition. The other way we said we could think about multiplication was in terms of geometry, the problem that Nathan just asked about, length times width, right? Area, length times width of a box. Today's topic is division, all right, division. Now, if multiplication can be understood in terms of simplifying, maybe, addition, what you know about division, what do you think division might also be related to? What other operation? Be related to? Mr. Mark.
Multiplication.
Okay, good answer. It's related to multiplication. It's one answer. There's actually 2. What's the other thing it's related to? What other operation? Think about long division. What What are you constantly doing? Finding a remainder. What are you doing in that problem? You're multiplying, but you're also what? Anna?
Subtracting.
You are subtracting. Right. So, there's two ways that we can look at division. One is, would you go around that way, please? Oh, you gotta go right here. Would you go? Have a good day. You're excused. I forgive you. Multiplication and subtraction. Wow. I feel like I'm on stage and there's a theater. People are running back and forth behind stage right now. Anyway. Okay, so multiplication and subtraction. For instance, if I have a problem, and this problem is given in your book, if I have a problem that says 12, and there's a couple different ways that we can say 12 divided by 2. We can write 12, fractional bar, 2. We can also write 12 divided by 2, right? And really, either way says 12 divided by 2.
Now you feel like you're in music.
12 divided by 2. Now, here's one way. Let's use the subtraction method first. If I take 12 and I subtract 2, I'll get 10. And then if I keep subtracting 2, 10 minus 2 is 8. Minus 2 is 6. Minus 2 is 4. Minus 2 is 2. And I'm running out of space. Minus 2 is 0. Now we can ask ourselves, how many times did I subtract 2? Well, here's 1 time. Here's 2 times. Here's 3, 4 times, 5 times, 6 times. So from the perspective of subtraction, division is how many times am I subtracting 2 from 12? And the answer to that question is what we call the quotient. 6. Right? And you all know that 12 divided by 2 is 6. Right? Now there's other ways to think about it, but that's one way to think about it is in terms of subtraction. And our good friend Harold, all right? Our good friend Harold's going to be quizzing you in terms of thinking about it in terms of subtraction, so I wanted to show that to you. It's kind of interesting. I also sent to all of your email accounts, that is if you have a RenWeb account. So I don't know if everybody's set up on RenWeb, but if you have a RenWeb account, you should have received an email from me about an hour ago. And it showed this, and I'll show it to you here. I think I brought it along with me. A fun 16th century division problem. Yeah. Wow. You know, I think Algebra 1 used to be more fun years ago. I don't know if you can see this picture or not, but I'll try to show it up here closely. And open your email accounts if you can't see it later on and take a picture, or take a gander at the picture.
That's the vision.
It's a division problem from the 16th century by some student with a lot of artistic flair.
Yeah.
Okay, let's just say artistic flair. And it takes some understanding of this problem from, first of all, realizing the difference in how numbers were written. That's one thing. We write numbers slightly different today than they did in the 16th century. But the other thing that I would note is that there is a picture. A picture. And this galley form of doing long division, the way that they were taught to do long division, which was a series of subtraction problems, because long division is a lot of subtraction, the result had the artistic effect of looking like a boat. Now you can say, well, I can make it look like a lot of things, and that's true. Okay? But they envisioned it in the day as a boat or a galley. And so it's called the galley method for long division. And you can see one student's artwork. The answer, which, if you take a close look at this math problem, the answer of which was written in the tail, which is sticking out here at the very end, this tail. And that's where the answer was to be found. So if you were to turn in your homework assignment, in this class, whoever this ingenious math teacher was, would have required the students to have done the long division. They would have incorporated a little art into the math. They would have drawn a picture of a boat, so it looked artistic, and this would have been the homework or the seat work that would have been done. So I'm not going to have you draw any pictures.
Thank you.
I'm not going to have you draw any pictures, but maybe a little artwork in mathematics is okay, right? It belongs there. It's okay. Now, that was the example of division understood via subtraction. If you take the dividend, the top number here would be called the dividend. Or in this problem, the first number would be called the dividend, 12. Divided by, the second number is called, anybody remember? We sometimes call this a numerator when it's a fraction, I know that, and a denominator. But when it's a division problem, what's being divided is called the dividend. And how many parts it's being divided into is called the, Anna?
Divisor.
The divisor.
Oh, sorry.
Somebody said divisor. Whoops, divisor. Okay, so the divisor here is 2. All right. The answer to a division problem, of course, is called the quotient. So if Harold asks you to find the quotient of some problems, he wants you to divide. All right, he wants you to divide. The other thing that's true is that when you have a dividend, 12, whoops, not a good color. Let's try it better. Let's go back to red. When you have a dividend, 12, and you have a divisor, 2, and an equal sign of 6 quotient. This is also true about division. The quotient times the divisor equals the dividend. The quotient times the divisor equals the dividend. All right? Now, this is Division 101. You've probably been doing this and you know this for a long time. All right? But I just want to update your vocabulary, get it fresh in your mind so that you're ready to do some of the division problems that Harold has in store for you as you enjoy lesson number 4, okay? So those two things I think we need to note in order to do the homework assignment for tomorrow. One, that division is a series of subtraction problems. The number of subtraction problems gives you the quotient. The other thing that's true is that the quotient times the divisor equals the dividend from a multiplication perspective. Does anyone have any questions about that? Now, as a child, we all know that Harold must have played what game?
Math tricks.
Well, he probably played math tricks, but he probably also played marbles, right? And you can bet that Harold has a way of representing division problems with marbles.
Oh my gosh.
So, for instance, if I have this marble is fading, that marble is fading. I thought that I brought, oh, let's try black. if I have a marble, 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 and a marble, a marble, a marble, and I write these marbles this way. All right, everybody see that? 3 marbles, red line. 3 marbles, red line. 3 marbles, red line. 3 marbles. Now, based upon what you know about division, give to me a division problem. That includes a dividend, a divisor, a dividend, and a quotient. On this problem, 3 marbles, 3 marbles, 3 marbles, 3 marbles. And I'll give you a hint. There's at least 2 of them. Mr. Mark.
12 divided by
12 divided by 4
equals 3.
equals 3. That is true, and that is one answer. So you have one answer to this. This also represents another problem. What else does it represent? It's another way of looking at the same problem. Maybe before I do that, let me explain where Nathan got his answer. There are 12 total marbles. If you divide them into 4 groups, there are 3 in each group. There are 12 total marbles. If you divide them into 4 groups, there are 3 in each group. So 12 divided by 4 equals 3. What's another way of representing this problem? Elizabeth?
12 divided by 3 is 4.
Yes. This also says I have 12 marbles. If I put 3 marbles in a group, there are 4 groups. 1, 2, 3, and 4. Right? So this marble problem represents at least 2 division problems. 12 divided by 4 equals 3, tells me how many are in each group. 12 divided by 3 equals 4, tells me how many groups there are. So there's 2 ways of looking at the same problems. You might have a question about if Harold throws a marble grouping at you, do you have any questions about how to represent those as a division problem? All right. Turn with me then, please, to your textbook, page 24. Page 24. Your assignment is on these pages. 24, 25, 26, let's see, 24, 26, and 27. Let's take a peek at those. Now, look at set 1. You should be able to do the first problem in your head. What's 500 divided by 10? Do you see problem number 1, page 24? 500 divided by 10. 500 divided by 10 is?
50. 50.
50. Right. Correct. 500 divided by 10 equals 50. Exactly right.
Whoa.
Yeah. So these are going to be simple division problems, right? Now you also have decimals. You know how to do decimals, right?
Yep.
So look at problem number 7. If you take 2.5 and you divide it by 4, what is that? What is the quotient?
No.
2.45 divided by 4. What is the quotient? Nathan.
0.6 1 0 5.
Okay, Nathan says 0.6105. let's find out. Do it long division. If I take 2.5 divided by 4, right? Bring my decimal straight up. 4 does not go into 2.
Wait.
4 does go into 25.
Scratch that 0.
6 times 4 is 24. Subtract. 25 minus 24 is 1.
Scratch that.
Bring down a 0. How many times does 4 go into 10? 2. 2 times 4 is 8.
That doesn't.
Subtract.
Next one.
You get 2, bring down another 0. 4 goes into 25 times. 5 times 4 is 20. 20 minus 20 is 0. I'm done.
I said
So-
scratch that 0.
The correct answer is 0.625.
That's better.
Does anybody have any questions about dividing when you have a decimal? Okay, you will have a couple more problems like that. Now, look with me at, we'll look at some set 2 problems. Look at problem number 9. Write the following number or expression for each of the following. 9a. You can almost do these in your head, right? The quotient of 12 and 3. Now, I want you to be careful when you read Harold's problems. 12 and 3, the quotient of 12 and 3 means that you take the first number and you divide it by the second number. Okay? So the quotient of 12 and 3 is 12 divided by 3. So what is 12 divided by 3? Elizabeth?
4.
Right, so 12 divided by 3 equals 4. So you would simply write down on your sheet of paper 4. You want to write down 12 divided by 3, that's fine. Now, look to 9C. 9C. There Harold says 7 divided by x. 7 divided by x. How can I represent that? Either as a number or an expression. 7 divided by x. Anybody? There's 2 ways. 7 divided by x, or you could write 7 divided by x. Okay, 7 divided by x, written either way. Sometimes Harold throws in some review problems. Look at letter H, 9H. The result of subtracting x from 10. What's that expression? Elizabeth?
10 minus x.
10 minus x. Okay, questions on how to do problems like number 9. Now, look at problems like number 10. Number 10 says the figure below illustrates 2 division problems. 6 divided by 2 equals 3, and 6 divided by 3 equals 2. So Harold's written for you marbles divided into groups of 2 into 3 groupings. 6 divided by 2 equals 3 tells me how many groupings there are. 6 divided by 3 equals 2 tells me how many marbles are in each group, because Harold's always losing his marbles and we're trying to collect them for him. Letter A, top of page 25, was the example I did for you about 5-10 minutes ago, right? You have 12 marbles. They're divided by 4. There are 3 marbles in each category. So, for instance, letter A would be, as we wrote earlier, 12 divided by 3 equals 4. And, we want to write an and here because both of them would be required. 12 divided by 4 equals 3. So in a problem like 10A, top of page 25, it would be necessary to write down both of those problems. It says what division problems, plural. So there may be one or there may be two. All right, look at letter B. Give to me division problems represented by Harold's ordering of marbles. Anybody? Elizabeth?
16 divided by 4.
16 divided by 4, and you have to finish it.
Equals 4.
Okay, so the correct answer would be 16 divided by 4 equals 4. You want to write the entire thing down. Is there any other way to represent that? The answer is no. You just so happen to have 4 groupings, and there happen to be 4 marbles on each grouping, so 16 divided by 4 would represent both cases. How many are in each group, and how many groups there are. Does that make sense? So this would be the entire answer for a problem like 10b. 16 divided by 4 equals 4. Is there a question? All right, look with me at number 11. These are super duper easy because here Harold simply wants you to, quote, check your homework by writing the multiplication problem that would check each of the division problems. So, in letter A, you have the division problem, 15 divided by 5 equals 3. What is the multiplication, hello, the multiplication problem that checks this problem? Right? So, on it.
5 times 3 is 15.
Yes. 5. We can put a solid dot there. 5 times 3 equals 15. Done. So here's what you would write on your sheet of paper. 5.3 equals 15. Questions? Now, don't get thrown. Look at a problem like E. E. Look at E. E says x over 10 equals 7. What's the multiplication problem that checks it technically? Nathan?
10 times 7 equals x.
Yes. So, even though you're maybe scratching your head, you simply take the bottom number times the quotient, give you the top number. That is the standard form for every one of those problems. Okay?
Yes.
All right. I think the rest of these problems are self-explanatory. Have at it. Your assignment is to do set 1 and set 3. For tomorrow.
Blame it on me.
Goodbye, friends.
Alright, thank you.
You're welcome.
Bye. Bye.
I just turned it gently.
I think you're.
And he
It doesn't make
came in and said, her turn, this must have turned it pretty hard. I'm just like,
do 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 do.